slides just as a kind of intro to Kotlin Multiplatform, and then we're gonna work through a kind of intro to KMP code lab that JetBrains has on their website. So for this week, like we call this the Kotlin Multiplatform and AI Code Camp, but the focus for these first couple of sessions is going to be on the Kotlin Multiplatform side. Yeah, just kind of a rough schedule of how the next couple of weeks are going to look. So today we're focusing on Kotlin Multiplatform for shared logic. Next week we'll do a similar lab that's around Compose Multiplatform and shared UI. Third week we'll talk a bit about libraries and some other advanced topics, and I'd love to hear from folks who are following along and stuff if there's topics you'd like to have covered in that third week or anything you'd like to kind of hear more about. And then we'll take a week off Labor Day, and then September 10th, we'll have a session on using the Gemini APIs with Kotlin Multiplatform. I probably forgot to introduce myself. My name is Russell Wolf. I'm a GDE for Kotlin, and I do some open source stuff. So I have a library called Multiplatform Settings that's essentially shared preferences for Kotlin Multiplatform. So it lets you do simple key value storage. And I'm way overdue to get the next version of that out. So feel free to get mad at me for that. But we're focused, on kind of our intro to KMP stuff for today. So, so what is Kotlin Multiplatform? And I can't ask folks to. I'm not looking at the chat, so I can't ask folks to raise their hand. But I'm curious, kind of roughly, how many people have tried it and how many people haven't?
I've tried it once.
But yeah, feel free to drop in chat and so we'll tell me.
No responses yet in the chat.
But what it is for those who aren't yet familiar, Kotlin Multiplatform lets you run your Kotlin code not just on the JVM or on Android, but also on other targets. So in addition to running the JVM, you can also run it in the browser through JavaScript interop, also through WebAssembly interop, and on iOS and other Mac devices via Kotlin Native, which is essentially C-level interop. And the thing that I really like about Kotlin compared to other cross-platform technologies is it's very focused on optionality. So unlike things like React Native and Flutter that really kind of they're kind of big decisions to adopt in that they're going to have much of a larger impact on your app architecture and things. Kotlin does its code sharing where your shared code is just one more library in addition to all of your native libraries, and that can be as big or as small as you want it to be. So you get a lot of flexibility to make things work for your team and your app and your use cases.
So there have a couple of folks responded in the chat, like Mark said that he's getting started with Hello World. Someone else says that their employees Play Store app is KMP and uses shared preferences library. Oh, uses your shared preferences library. Nice.
Cool. So yeah, good to hear that some folks have some experience. So yeah, like what we'll be working through today is essentially like just beyond Hello World.
Do you want to wait for questions or throw them out?
If you have questions, throw it out, sure.
Okay. Does multi-platform support some of the iOS versions like iPad OS, TV OS, etc.?
Yeah, so question that folks online can hear is kind of what other parts of the Mac ecosystem does Kotlin Multiplatform support? So using the same kind of target as iOS, you can target iPad naturally, and then there's separate targets for TV and watchOS.
Okay.
And I can like when we're getting started, I can show you kind of how that would work.
Okay. Good. Thank you.
So yeah, a couple more notes on KMP. So you might have heard the acronym KMM thrown around. It's essentially deprecated at this point. So I like to just kind of point out when I'm giving talks these days, the kind of preferred nomenclature from JetBrains these days is don't say KMM anymore. And even avoid KMP sometimes, like Kotlin Multiplatform is the sort of branding that they're going for, or at least kind of say that before you say KMP. So it's clear what you're talking about. And in addition to I like it, it's gotten some, like one of the reasons that I like it is it has a lot of support from some of the organizations that I trust. And so JetBrains, like if you've been working in Android Studio, you're used to the wonders of JetBrains IDEs. They're a very developer-focused company. They are like they made this really nice language, and they're all in on making it run on all the platforms. And then Google announced at Google I/O this year that they're throwing their support behind KMP2, specifically focused on the shared business logic use case, which is what we'll be going through today. Like they're using it internally for some of the docs and the kind of like Office suite that they have, and are also kind of investing heavily in some of the infrastructure side of things. And so they're like both those companies are kind of the keys of the Kotlin Foundation, which keeps the language going, and they're all in on KMP. So a brief rundown of kind of what Kotlin Multiplatform looks like. You can kind of, for a visual, kind of think of this Venn diagram, where on the left side, if you're an Android developer, you're used to writing in Android Kotlin. And you can sort of imagine, and you might do this sometimes if you're trying to make your code more testable, for example, you can imagine kind of paring away the Android specific bits of it and just having some kind of like platform agnostic bit in the middle. And what Kotlin Multiplatform lets you do is when you've kind of like pulled out that platform agnostic code, you can also run it in other environments. So you can take that common chunk and add it to an iOS app, while also having Kotlin code that can talk to iOS and talk to iOS APIs kind of wrapped around the outside. And then the KMP toolchain kind of like ties all of that together. So it will pull the right sources in when you're doing a build for one platform or the other. And obviously you can also throw in web and other platforms into this, but it makes it again a little more complicated. And as far as kind of a little more detailed look at what the app structure looks like, so that Venn diagram maybe is the module on the bottom in this diagram, which is kind of where your shared code lives, and then that is a library dependency of your apps. So in the sample that we'll be working with, there's an Android app that'll be called Compose app, and that will consume the Android side of the shared module, which will be the Android component again. And then there's an iOS app, which will be written in Swift, which consumes the iOS side. So with that, we're gonna work through this getting started tutorial. So you can grab kind of follow along from that URL. And I will kind of jump over to that. But while we have a quick pause, does anyone have questions kind of before we jump in and get started?
Which version of Kotlin?
So we're going to be using version 2.0 of Kotlin, which is recently out. 2.1,
2.0
dropped, or 2.0.10 might have just dropped.
Right.
And 2.0.20 is close to being finished, but 2.0 is good enough. 2.0 is kind of they did a big rewrite of the compiler over the last couple of years, and 2.0 is kind of the culmination of that, which is pretty exciting because it's going to unblock a lot of other new developments and stuff.
Would you go through this?
Yeah.
Would you show where you set up 2.0 in the IDE?
Sure. Yes, I can show some of that. So that link I gave you kind of goes to this tutorial page. So we sent out ahead of time the first page of this, the kind of environment setup. So hopefully folks have that running. That was just to try to avoid a scenario where folks are trying to download things and get it all working last minute. So where I'm actually going to start is the kind of currently supported way to the currently supported kind of new project wizard is this website here. So if you go to step 2 in the tutorial here, the first thing I link to is open the Kotlin Multiplatform wizard. So that will take you to this page here where you can set up your project name. The thing to make sure you check here is click the do not share UI option in there. And then you can click download, and it's gonna just download a zip file of that starter project. And then we'll kind of step through that in here.
Did you also select?
It has it. Sorry.
Did you also select desktop and web, or just Android and iOS?
I just did Android and iOS.
Okay.
Like you could do the others. We're gonna like the code lab's just gonna do Android and iOS. If you want to do other platforms, like you can add those in, and you can change that manually later on if you like. So once you have done that, and I'm kind of cheating because I had it already downloaded. But I can give you kind of a quick look around what this stuff looks like. One important first step is when you're in Android Studio, on the left side, you have your kind of project view. And Android Studio really likes this Android view here. For KMP, you actually want to be in the project view because the Android view will kind of hide some files that you actually need to be able to see. So make sure you switch that over. And I'll give just kind of a quick rundown and answer some of the questions that came in the beginning. So in the, there's a couple folders here. So the shared folder is where the shared code lives. So that has a build Gradle file that's applying the multi-platform plugin. The iOS app has an Xcode project in it, which is where the iOS side lives. And Compose app is actually in this template, it's structured as another multi-platform module, but it only has Android code in it. But if you wanted to migrate this to having some shared UI, you could just add an iOS source into this module or add more common sources. So there was a question earlier about adding other targets. So in this shared build.gradle, there's a Kotlin block, which is where we declare what are the different targets that our app is going to support. So Android target is for Android. These 3 iOS targets are for iOS. So these are ARM64 is the iOS device target. x64 is the simulator on an Intel Mac, and simulator ARM64 is the simulator on a ARM Mac. So depending on which desktop platform you're on, you might only need one of them, but if you're kind of sharing among a team with different laptops and stuff, you usually want all 3. And if you wanted to add other Apple platforms, you can just add some to that list there. So like you have watchOS, it would be, should I put it here? So there's a couple different watchOS targets and simulators.
Does the Kotlin documentation contain a list of those
Yes.
choices?
Yeah.
Okay.
There's a In the docs somewhere there is I'm not gonna find exactly where it is. But
That's okay. You don't need it.
Can you repeat what the first ones were, Russell, please?
repeat, sorry.
The first three that came in by default, can you repeat what those were again?
Yeah. So iOS x64 is the simulator on an Intel Mac. iOS ARM64 is an iOS device, and then iOS simulator ARM64 is the simulator on a Apple Silicon Mac.
So I would guess that because iOS ARM64
Yeah.
is present,
Yeah.
that I can plug in my iPhone
Yes.
to Android Studio and have the app transferred to that iPhone, to the physical iPhone.
Yes.
Cool.
Yeah. It sometimes doesn't work through the Android Studio plugin, though that might have been solved by now. I haven't done it from that side in a little while, but yes.
Okay.
Yeah,
And
and I'll like we'll get to kind of what that looks like from the Xcode side too.
Okay.
it's actually Xcode that does that, but
Well, you can do it from
Android
either.
Studio
So
will-
if you have the plugin installed for Android Studio, then you actually get this iOS app in here where you can run it.
Okay.
iOS app. So I can, as a quick demo, kind of show like we can run the Compose side and run
I think it issues Xcode commands, right, to make it all happen.
Yeah.
While you're running that, we have a question online. Mark asks, do you know if Project IDX supports Kotlin Multiplatform?
I think the answer is no, but I have not done anything with IDX, so I'm not actually sure about that.
Maybe in future, because recently they opened the waiting list for Android Studio.
Mhm.
So maybe in future.
Yeah, my sense last time I looked at it, which was a couple months ago, was it was more web focused than
Yeah.
mobile focused. But I have not caught up recently, so I don't know kind of to what extent that's changed. So what the sample app is, we're running now. A button, click it, and it animates in a little thing that says, hey, actually no, that's the old one, isn't it? This is going to be the end state. Sorry, I had the end of it already running from a previous test. But basically, it basically has a button that says, shows a picture and says what platform you're on. So yeah, here's what it actually looks like. Hello. And the iOS is still loading. So the iOS builds can take a little bit of time. So just kind of be aware of that. Usually after the first build, it's a little quicker where it just kind of needs to get some things warmed up in the cache. But you can kind of click into it and it gives you some console output if you want to follow along kind of what it's trying to do. Right now it's just kind of a dump of the environment. But roughly what it does is it kind of hooks the Gradle build into the Xcode build, and so when it's building the iOS app, it's gonna run Gradle, build the shared code, wrap that into a framework, which is the iOS dependency format, and then the Xcode project is configured to know where to find that framework, and then it'll kind of pull that in and build with it and build the Swiss code on top of it. So iOS app is coming up now. So have folks been able to successfully clone and do a quick build and make sure everything's working? Anyone have kind of questions? We start getting
Can
into
you drop the link that we're supposed to clone into the chat?
Yes, I can. It's the Kotlin Multiplatform wizard on the let's do KMP.com. It's actually the easy code ever.
Oh boy, infinite.
Yeah, sorry. It's your fault for asking me to do something.
Yeah.
Yeah, so if you have that, so this goes through kind of some details about what you can find in there, which I've mostly, I think, talked about. If you, anything else, if you are used to kind of doing Gradle configuration from the Android side, like the Kotlin block is all the new stuff. There's most of the new stuff, and this Android block should be similar to what you're used to. One thing I do want to call out, because the tutorial hasn't updated to this, but the project templates have. So the project templates are using version catalogs. So it has all of the dependencies and versions and stuff in a file. In this file here, libs.versions.toml. The CodeLab website hasn't been updated to that yet, so it's going to just hard code all of its versions. So just be aware of that difference when you're comparing what's on the website to what the project looks like. So, and this will be the answer to Paul's question from earlier. So in this TOML file, so a talk here is kind of versions of a bunch of things defined, and then the next section are libraries and plugins. So these get converted into the kind of this like dependency notation here, or there's not any other dependencies in here yet. But the versions, so like the Kotlin version is coming from this 2.0 right here.
Yeah, I see it. I had at some point I had come across some information that seemed to indicate that there was a setting in Android Studio's settings that you needed to toggle for enabling 2.0.0. Is that obsolete now?
I think you should get that automatically when you update, but just in case, so if you go to Tools, Kotlin,
Where the settings now?
yeah, so like in Android Studio,
Right.
you go to the Tools menu, there's a Kotlin, and then there's configure, or no, is it configure Kotlin project? No, sorry, I am misremembering where this lives. Maybe some settings then. There is somewhere like a Kotlin plugin version. Oh, actually, no. As a 2.0, I think you probably don't need it because it's tight. Oh no, I'm not sure. I'm not sure off the top of my head, but there's. Yeah, I remember where it lives in.
Right. Configure Kotlin in project. Under that menu gives you the option to choose. And I came up with 2.0 RC2. Configure Kotlin in project. That's a drop down.
There's not just a thing that does an action like that, but there's a thing that has a menu with some things where you can tell what version to use. I don't know.
Yeah, that's what I'm seeing, but it might not be on your version of Studio. I'm on older version, and I have a drop down, and I can see 2.0 RC2. So
yeah, you might want to move that to 2.0 if you can, but if you're on an older version, you might not be able to. But anyway, let me get to other stuff.
Well, to belabor that point,
Yeah.
I see if I go to Android Studio settings,
Yeah.
And they go into, I think it's languages and frameworks.
Yeah.
There's a
Oh, maybe that's about it.
there's a button for enable K2
Mhm.
Kotlin mode.
Yeah.
And so I tried that once and got into all kinds of trouble. And at this point, I think I'm happy to just do the
Just leave it at the default.
TOML
Uh-huh.
solution.
Yeah, so they're doing slightly different things. So the setting the version in the TOML is what's happening like as part of the build.
Yes.
The IDE stuff is for like how the IDE is doing its code highlighting and that kind of stuff.
Okay.
So when there's a mismatch there, like you can sometimes get like red code that actually works or the opposite.
Okay.
But
All right, that
I think,
explains it.
I think in, I don't remember exactly what version, but I think if you're in a recent enough Android Studio, you should just have everything already in 2.0 for free.
Okay.
And nothing we'll be doing tonight is going to care about the difference.
Okay.
So kind of moving on here. So we have a sense of the project now. So the first thing we'll look at is in our shared code. So our shared code has 3 different source files. So there's a Android main, a common main, and a iOS main. You would also have test equivalents of all of those. We're not going to talk about unit testing today. But if you kind of had the same folder structure in common test, Android test, actually it would be Android unit test, just because the Android targets are a little bit weirdly named. And iOS test, then you could write unit tests in those folders, and you could have like common or platform specific testing. But we will open up the greeting file. So greeting is just saying hello platform.name. Platform here is a function that's defined in this platform.kt file. And it has this keyword expect. So what's happening here is in the common code, we say we expect a function called getPlatform to exist, but common doesn't know the implementation of it. The implementation comes from the platforms. So if you look at, we have platform.iOS and platform.android. So they have actual function declarations that pass the Android implementation or the iOS implementation. And then the rest of this is there's a platform interface that there's an iOS and an Android implementation of. And the pattern there is one I often find useful where, like, for the most part, I would rather use interfaces where I can to define my common code, because it gives you the flexibility that you get even in JVM code where you can, if you wanted to, you could have, like maybe you have like a test Android platform and a broad Android platform or other kind of variations like that. If you just had like an expect class, you could only have one actual definition of it. But having the function can be nice because it gives you a default. So you can call getPlatform to get a default platform, but you also could just instantiate whichever one you want. Imagine like a more complicated app that has this kind of structure to it. So what they got us through is if you, so we want to add a bit of randomization to this greeting. And if you're used to Android code, then you might do that by java.util@random, but that won't work in your common code. So if you were to try to add this code to our greeting here, which it's a little they kind of hide the class in the sample, so this is funny, but you can actually import java.util@random into common code because it only works in JVM code. So if you didn't have the iOS targets defined, this would be legal. So Kotlin is smart enough to kind of find the common API of whichever platforms you have declared, and that will be what's available from common. So like if you just had Android and JVM targets, then this code would work. But because we have iOS targets, it doesn't. So we'll get rid of that and let it import Kotlin.random instead.
Okay.
There's always a risk if you rely on that last thing you say, like Android and JVM have it.
Yeah.
But if you then ever want to add a platform to your
Yes.
app, then you screw it, right? And it's better to
Yeah.
just rely on the standard lib.
The column.
Correct.
and
Yeah,
the
yeah,
lib.
Yeah. Like generally, it's better to
Yeah.
to not rely on JVM things in your common if you just have JVM targets. You can have kind of multiple layers of shared code, where you have like a Android or JVM share that talks to JVM things, and then a common everything underneath that.
More of a hierarchy, like
Yeah,
a little
yeah,
extra in the middle. Yeah,
Yeah.
there's some commonality.
And that's like usually if I were doing something like that where I'm adding targets, like after I already have an existing thing, I would probably set up that kind of structure
Yeah,
because
that
it
makes
makes it
sense.
easier to
Yeah.
migrate.
Beth has a question.
Yep. Beth, go ahead with the question. Where is it? Where is the step?
Sorry, I was looking for the word expect and then it showed up in a tooltip.
Sure. Yeah, it's in.
Platform.
Sorry, I got rid of it when I. Oh no, sorry, it's in platform. Yeah.
Yeah, okay. I saw it in a tooltip and the other file greeting, but yeah. Okay.
Yeah, sorry about that.
The text is a little small, I think, is the real thing for me to
Sure.
tell
Yeah,
you.
sorry. I'm.
So when you change windows, I'm missing it a little bit, but yeah, cool. I can expect
I
that.
imagine because we're all looking at screens that. it's-
Yeah, switching windows too. Yep.
Sorry. So again, so yeah, then the other thing that breaks in this greeting is Kotlin's random is an object rather than a class. So you have to get rid of that parentheses. And now this should work. I'll just if I run this now, I'm going to read a little bit, and it should, and we'll see it. It'll switch between hi and hello each time, or randomly, rather than saying the same thing every time. So, hello. Yeah, there we go. So hey, there's some Kotlin code running in iOS. We changed it. It still worked. So this kind of continues and does some more adjustments to that, which I'm just trying to pay attention time-wise if we want to go through kind of every step of it, or if we want to skip ahead a little bit. So yeah, I'm going to jump to specific stuff. So so they have one more step where you kind of just adjust the greeting, add some extra logic to it. Highlights the fact that you can talk to other kind of string manipulation APIs. So you can call platform.name.reversed and say it backwards. And then sorry, this next part kind of goes through the anatomy of the platform files, which we talked about a little bit already. But I'll highlight, so in the Android platform, we're talking to build.version.sdk.int, which is like the build class, the Android OS build class they use to from Android. On the iOS side, it's talking to these UI device APIs, which are kind of how where iOS has essentially the equivalent information. So they actually, interestingly, kind of implement these slightly differently, where Android's just spitting out a number and then saying Android in front of it, whereas iOS is dynamically getting the device type which I think would mean if you were to add WatchOS or a tvOS target or something, that it would it would render that correctly if you ran that simulator. But it also, like, this is kind of the equivalent to version name rather than SDK int on the Android side. So that you should probably actually do, I don't remember exactly what it is. What is it? Name or code name? But anyway, not a huge deal. Or maybe version name. I don't remember. But anyway, so that's kind of what the what that kind of platform class looks like, which we've talked through a little bit already. They have this kind of extra section that digs into that a little bit more, kind of runs through another example of it. So if you're confused or want to kind of like follow up more on how things like actual and code code work, you can go through that. But otherwise, yeah. So you can. We showed this already, but you run on Android. Run this Compose app, and you can go in and edit configurations if you want to, like if you wanted to change the iOS settings. So it's going to kind of pick out the default iOS like simulator target to use, but this will kind of dynamically populate with whatever simulators you have installed. I think there, at least until recently, was a bug where if you had non-iOS targets in here, it would stop working. If you added TVS, then this dropdown would stop working. So watch out for that if you're playing with that. But it'll still work if you're running it from Xcode, which we'll get to that at some point later.
Did you address Alvin's question? They had their hand up.
What was the question?
I don't think they have asked. They just have their hand up.
Oh, sure. Yeah. So I'll pause if anyone wants to ask a question.
Blind developer, if you wanted to ask a question, you could. I was wondering how you started the simulator, Russell. That went by quick.
Yeah. So in the dropdown where you normally have run configurations, this template project should have a Compose app and an iOS app options. So iOS app will run the iOS simulator, Compose app will run whatever Android thing you have connected, which will default to the Android emulator. So this is the part where, like, I'm not sure if you, and then you can go into edit if you want to change what the target is.
Yeah, I didn't see anything under, again, I'm on an older.
Yeah, it might be older Android Studio. You do have to have the Kotlin Multiplatform plugin installed for that to work, which was part of that framework page.
Yeah.
On older versions, it might be called the KMM plugin.
I mean, I got the project right, so.
Yeah. No, but there's like the for the IDE support, you have to have the right plugin installed.
I'll investigate after class.
We'll get to the Xcode side of it, and then you can run it from there.
I thought I might also drop the Slack team invite so that if people have questions after class, they can find us on the Slack team in the questions and answers channel. So if you're not already on the Boston Android Slack team, I dropped a link in the chat, and you can find us after class as we prepare for the second class. You might have questions, all those kinds of things. So cool. Thank you.
All right. So that's actually do it if it's good, and we can show things from inside too. So where are you? So So wherever you cloned the project to, if you open Xcode, go to open project, and then go to the root of where you cloned the project to, and then one folder down, open up the go into project name / iOS app, and open up the iOS app.xcode proj. That's what you want to point Xcode to get the project open. It'll give you are you sure you want to trust this? You can say yes, because you know where it came from. Move this over, which on screen.
Yeah, I was able to just double click on it inside the Android Studio app, and it opened.
Do that as well. Depending on, I just don't always trust that, because it's like under the hood, that Xcode project is a directory with some metadata and other artifacts in it, and sometimes Android Studio wants to just open the folder when I do that. But whichever way you want to do it, open it up in Xcode. And you can click this arrow in here, and that will also run the because it's on my desktop, it needs to be able to see this. So you should be able to click there and run it in the simulator from Xcode. So if you weren't able to get it running from Android Studio, hopefully you can get it running from here. And that'll take a minute to load. While we're waiting for that to load, just kind of a quick little Xcode primer. So on the left here in this default view is what looks a lot like Android's kind of view of files and things, but it's actually it's not a direct mirror of the file system, because Xcode is confusing and complicated. But you do have this iOS app directory, which does match the iOS app directory in our Kotlin project. It has a couple of Swift files in it. So there's this app file is kind of the top level entry point, and content view is where the UI is going to be defined. And then if you click this, the kind of top level iOS app here, and it's going to take a minute because it's also loading this other thing. This is kind of where different configuration and things live. So when you're kind of modifying things in the Xcode project, you sometimes have to mess around inside this view. Let's let this finish loading. It's almost there. I guess another thing to point out, so there's a couple different kind of options across this top left level in Xcode. Some of the ones that will come up more often, this kind of warning thing will show different warnings that come up. This one here, you can separate, if you set breakpoints in your Swift code, it'll list them there. This far right one is a build output log. So like while that build was running, you could see the output inside of here, and somewhere at the top of it is, here's where it's running the Gradle build as part of that. If you're familiar with Xcode but not with the KMP side of things, you can kind of you may know to look at things like the build phases of the Xcode project, which is where, sorry, it's the wrong thing. This is where it's actually doing the where it's actually hooking into Gradle. Is it adds this extra step to say that adds a bash script that says run this Gradle command, and then there's some settings that are linking the framework output of that into the Xcode project.
Is it safe to say that you try to avoid dealing with Xcode like the plague?
I don't like Xcode very much as an IDE, so in that sense I try to avoid it. But it is, for the most part, where I write Swift code if I'm writing Swift code.
Okay.
So in the future, the kind of long-term plan from JetBrains is They're supporting kind of multi-platform Kotlin and Swift development from their new Fleet IDE. And so like that's currently in, I don't remember if it's alpha or beta for that use case, but it's or maybe it's still experimental, but it's kind of like early stages now, but that's kind of like the long-term plan for what's going to be the supported IDE. But there's always going to be some need for Xcode because the JetBrains tools can do the code side of things, but they can't usually do the like configuration side of things, just because it's always changing version to version, and Apple likes to keep things locked down.
They're difficult, yes.
Yeah. So yeah, so that's Xcode. So hopefully folks have been able to like run a build from Xcode and get that working.
Yeah, I got it working from Xcode. It looked like I didn't have a simulator downloaded, so obviously Studio wouldn't have been able to start.
Okay, yeah, that might have been the issue. Yeah, I don't remember if that pre-work page highlighted that specifically, but it's a good note to have that I'll try to remember for next time. So there's my list. So the if you go through on your own kind of these tutorials in more detail, you can like you can expand some of these other sections and kind of learn your way around some of the other options for how you run things. It talks about running on other simulators or running on a real device. And then they also link out to some other more advanced topics like running tests and things. So we'll talk about some of that stuff as we have time in the later sessions. But for now, we can jump to making some UI changes. So on the Android side, so going back into Android Studio, we're going to move up to the Compose app directory, where the Android code is living. So it has a common main and Android main directory, but for the most part, it's just Android main that we care about for this project. The common main just has a resource that's only being used in Android anyway. So you have kind of the users they're used to, and you have a cloud directory with some code in it. So we'll open that app up. So in where is this in? Yeah. So this kind of builds up a there's a app level composable. So that's the theme, does a little bit of scaffolding, and it like here's where it's calling to the shared code. So this greeting.greet, this greeting is the greeting from the shared code, and you can navigate into it if you do Command B, and it'll go to that greeting class. And that's probably a little small. So if you want to, so what the code lab has us do is, sorry, I'm stepping on something, is do some refactors in our greeting class. So we're gonna, and that just kind of makes it easier to add a couple different examples and things. So instead of sending a message, we're gonna change it to return a list. And then we're going to add a couple things to that list. And this should, nope, okay, I need a list. And it needs a, oh, because there's a couple things that we didn't do last time. Because of that section I skipped. I forgot to put a couple of little details in. So this will just let us kind of like, when we're adding more samples, we can just kind of do an add in here. So if you're not familiar with build lists, it's a nice way to kind of dynamically build a immutable list in Kotlin, where this will be like, you could do mutable list of and then kind of add things that way, or you can use this builder where it will it's mutable kind of inside these braces, and then once it returns, it's immutable, and you can just kind of call add inside of it. But only like it only runs that one time. So we can then kind of refactor the rest of our app level to call into that. It's gonna create a column, and for each string in that list, it's gonna render elements. Here. If you just kind of copy paste, it's going to, you'll need to kind of do all the missing imports, but it should default to all the right ones. And then if we run Android from here, and the idea here, like this is ultimately technically no different than if you had a multi-module Android app. Like, we've made some changes to our shared module, which is just to Android, looks like an Android module, and now we're making changes to the app layer to consume that correctly. And from the Android side, we get all of the right, like the all the like code inference stuff works right away, where it could immediately see that when we changed it in the shared code, that the calls on the app side were incorrect. Like, you start to fix things in, and it's not lining up right until you fix it. On the iOS side, it won't happen as quickly, where until you do a new build of the iOS app, it doesn't, like the Swift side doesn't know about any changes. So that's one of the things that Fleet does better. So play with that some if you're interested, but it's not quite all the way there yet. But it does a better job of kind of knowing cross-language when you make a refactor. So that side. So on the iOS side, we'll so we can go back to Xcode and open up content view. So if we tried to build this right now, I don't know if it'll actually break or not, because it might just kind of two-string it at the right time. But one thing you can kind of see is if you go to the green.read here, you can right-click and do jump to definition. And that's gonna, so this looks like just kind of like a big pile of text. This is the actual Objective-C header that Kotlin is generating to be able to access Kotlin things. So it's a bit messy if you're not used to looking at it, but it's a place you can go to troubleshoot things. If like, you can look at these Swift names to see what is the name that things are getting exposed as, in case it's not matching what you expect it to. You can see what functions are being exposed to Swift. Like certain things won't get exported if like if it's a Kotlin construct that Swift doesn't know about. So you can look at these headers to get a sense of if something's going wrong. Like, this is the source of truth of what is accessible with Swift. So yeah, we'll do this update to the Swift code to have it kind of do the same thing as whatever it was doing. The other thing I'll point out in this file, so the import shared in our Android, or sorry, in our shared code on the Android side, in our build.gradle here, we set this base name equals shared when we declared our iOS target. So this was just kind of in that template by default. But this is how you define what the import is that iOS is using to access your Kotlin code. So if you want to change that for some reason, you want to make it Kotlin or something instead, that's going to be the name that comes up here. The other thing I'll point out is, so this code is red right now because it still remembers the old way that greeting was defined until we do a new build. So I'm going to kick off a build now, and it should actually work. Assuming I didn't do anything wrong, but you have to kind of give it a moment to actually get through building. And you can watch it live in this last tab here that I've shown you before. So if you go to the rightmost thing in that left corner, you can kind of click on this build and see what step it's at. So right now it's running Gradle, just finished, and now it's doing the rest of the iOS build on top of it. And now it's finished. It should, yep, so yeah, now it's running that list. So yeah, so that kind of gives you a sense of where to go to make changes at the UI level for both the Android and the iOS sides. So for the next bit, actually, I guess I'll pause before we move on there. If anyone has kind of questions about any of that, or is bored because I'm moving too slowly, or is confused because I'm moving too quickly, feel free to pipe up or jump in.
No, the pace is good in my opinion.
So okay, we can.
Do you anticipate that you're going to get through shared code today? Shared UI?
Not today, no.
All right, then.
That's my plan for next week.
Okay, I was holding off on a question
Okay.
that is relevant to that. But I'll throw it out there now. It strikes me that it's probably a good thing for breadth of skill set to go through this at this level to understand how what Xcode is doing, how to make changes, etc.
Mhm.
But it also strikes me that I want to avoid that like the plague because it's so complex and it's just more learning, and there's a lot of learning anyway with Kotlin Multiplatform.
Yeah.
So, and if you're using material design or your app is material designed, that you would want to not get to this level. You want to avoid this level. And you would get there by using shared UI, where Compose is material design.
Sure.
So,
Yeah. So shared UI.
is that a bad idea for some reason?
Yeah. Let me. The question is essentially like, can you avoid all the complexity of Xcode by using shared Compose UI?
Yes.
And you can avoid some of it. Like you can avoid a bunch of the need to like write Swift code and stuff. But when a project reaches a certain level of complexity, you will almost always need to dive into it at some point. And so it's a good skill set to have, to at least be kind of comfortable with Xcode, comfortable building things from Xcode, comfortable navigating from it. But it's not a problem if it's like, especially if you're doing a shared UI project, it's not going to hurt you to not know it as well as you know Android Studio.
Right. Okay.
But I I generally I like knowing some things about Xcode because that it just again highlights some of the flexibility of Kotlin. Is like you're not. I want to be able to do something shared and something's not shared, and I need to know something about Xcode to be able to do that.
Is it almost true that you had to know a lot about Xcode when you first started off doing shared preferences?
When I first started stuff, yes, yeah, and the ways that you hooked into it from the Kotlin side changed a bunch over time too.
Yeah.
So the there is some complexity to that, which is getting hidden because we're starting with a template that kind of already has stuff set up. But if you're interested in those things, you can kind of dive into how it's configured, and some of this documentation will talk about it too.
Okay.
Russell,
Yep.
what about access to sensors? We're only talking about the screen.
Yeah. So for the most part, like my usual instinct with sensor related things is to do it from platform specific code.
Right. And just kind of, you have the platform specific code to read the sensor, and then you have something shared with a common data type.
You would have an interface like this that is, like yes or something, and give you platform specific implementations and define kind of what functions you need to be able to call from common for it.
Working on maps, location is, top of mind for me.
Yeah. So
I get it. Yeah.
And like there's for some use cases, there's libraries that exist that kind of do that wrapping for you. Like that's essentially where multi-platform settings started. Was I was doing a demo app that was talking to shared preferences on the Android side, and I had the kind of platform specific code for Android and for iOS, and kind of pulled that out as a library. So some people have done that for other use cases too. And there's, I don't remember if this links to different, like where there are different dependencies and stuff somewhere, but there are a couple different kind of lists of multi-platform libraries.
Hey, wait, is your library part of the tutorial lesson?
No, mine isn't. It is. Mine's in a couple of their samples, but not the ones that come up here.
Okay.
It's in the awesome collection.
We'll get to it later.
Yeah, it's in like the big lists.
Yeah.
But yeah. So for like generally the way that like talking about libraries, because that's where we're going next. There's like the way that Kotlin multi-platform libraries work looks very similar to what you're used to from Android, but where you configure them is a little bit different. Where in this is the shared build.gradle. Like for an Android app, you would have just kind of like had a dependencies block. And kind of throwing things in there. For multi-platform, you put it inside the Kotlin block in these kind of dependencies blocks here, and that lets you define different dependencies for your shared code and for the individual platforms, or for if you have kind of multiple levels of shared, like each one you can define different dependencies for that access what that source is able to see. So for this demo, I think we just use things in common.
So I did brew install my CocoaPods.
Yeah, we're actually going to not use CocoaPods for this.
That's probably a good thing. I've heard a lot of.
Yeah, like for a while, CocoaPods was sort of the easiest way to get things running quickly. Now they have these now that they have kind of templates like these ones that have the shared code configuration set up better, you don't need to use CocoaPods, and it makes it easier if you're integrating with an iOS project that's not using it.
So this is stuff that JetBrains is doing.
Yeah, like this is just like the project template that we started from. It
Okay, okay, got it.
has the wiring into the iOS dependency layer set up. So it's not set up well out of box to add iOS dependencies that you can see from your shared code.
Yeah.
But you could add a SPM module just for your Swift code and things like that.
So if you're integrating with a project that does use CocoaPods, you don't need to disrupt the CocoaPods. You can keep that isolated in the
Yeah, essentially.
module.
There is some documentation and stuff on all of that. Go through it in detail tonight, but
Yeah, I'm leaping forward. Sorry about that.
No, but they have this whole page. I'm talking about iOS dependencies, and they go through the CocoaPods version, the not CocoaPods version.
Yeah.
Yeah, like all of that is there. Like they've done a lot of really good work on this whole documentation site over the last couple of years. Like compared to the way things looked in 2018, 2019, it's real nice how much resources they have out there. But just so you get a sense of what KMP dependencies look like, let's add this common next date time. So you put it in that common main dependencies block. But the dependency notation is kind of the same that you're used to from Android. So you have the coordinates in the version. Under the hood,
Is that using TOML?
this is not like this is where the tutorial is a little bit behind the templates.
Okay.
So the tutorial is just kind of hard coding them, but it's giving me a little warning saying, and if I go into the alt enter, I could replace it with a catalog definition. I'm not going to do that just because I don't want to move too quickly and make it too confusing. But
Okay.
like yeah, you all of the stuff you can either use with a working catalog, or you can hard code it, or you can do whatever other things you might have done in the past. Under the hood, like there are separate versions of all of these dependencies for each platform, and there is a inside of this one called Kotlin Next Date Time. There's a metadata file that points to I'm Android, Kotlin Next Date Time iOS, et cetera, for all the platforms that it supports. And one thing to keep in mind about that is anytime you're depending on a library or writing a library, like a library has to declare what targets it supports, even if the code in it is all common. So like the library is going to produce some binary artifacts, and it needs to kind of know which platforms to produce them for. So when you're defining a library, you have to declare all those targets, and when you're consuming the library, it has to support the targets that you're using in the source that you're consuming it in.
It would be cool if Caleb could export some kind of intermediate format, right? Or almost like not the source code, basically that's what it becomes then.
Yeah.
What it would be.
Yeah. So there's
then you can just import it, and then it needs to be compiled still, but maybe just one less step.
Yeah. So they've talked about as a future thing, this kind of advanced Caleb format that could have like pure Kotlin libraries. It ends up being more complicated than you might think.
Yeah.
Because like what happens if Kotlin adds a new platform in the future, and this previously pure common thing like now calls into an API that new platform doesn't support. There's all sorts of like subtleties like that come up when you think about that. So they've kind of talked about that idea for a long time. I think we'll have some version of it eventually, but
that's why source code is good,
yeah.
because your source code is in your project, and your project defines exactly what platform you support, so you don't have that issue. But
yeah, but
just
then
if you
then
publish it, then it's no longer under control, and then then you don't know.
If it's source code though, then you might not have a repeatable build if you're building with
Exactly. Yeah.
If so, there's all sorts of complications that come up. But anyway, so we can.
So I raised my hand.
Yeah.
I was just noticing that we're getting close to time. And I
Yep.
wanted to make sure that you went over next steps and what we should do to prepare for the next class.
Sure. Yeah, I guess so. What this is going to continue going through, if we want to fast forward it, is so we're like by adding this Wednesday statement, we can resync, and then we'll be able to talk to the Kotlin X datetime library, which is just a common datetime abstraction, essentially the shared version of like the Java time APIs. And so you'll be able to, you'd be able to write code. So like clock is, it's kind of main abstraction for like getting a time source, and then it has time zones, names, and dates, and all of that. So once you have this kind of single declared in your common, then you can talk to those APIs, and you know how libraries work. You've probably done them on the Android side. So that lets you define the logic that's talking about library, and then call into it. And then like the next step on here, if you want to kind of continue on your own, add some other common libraries. So coroutines and serialization, you've maybe worked with on the Android side. I guess not everybody has. You can like this last step kind of walks through making a simple API request using serialization, coroutines, and KTOR, which is it's best known as a server framework, but it also has a HTTP client that is multi-platform, which lets you make web calls and things. You can use it kind of similar to how you might use OKHTTP on Android. So that's kind of what remains in here that we're not going through step by step since we're running out of time. Yeah, I guess where do I want to go from here? So the so the plan for next week is the next code lab is similar, but with a focus on shared UI. So hopefully you shouldn't need to do any more kind of setup work that you don't have, like the what you did last time to set your environment and stuff should still all work for that.
You're going to stick with Android Studio, or are you going to delve into Fleet at all?
So my plan was to stick to Android Studio just to not add the extra complications, but
okay.
If there's interest in Fleet, I can play with that some and try to get some ways around it. Yeah, like there's lots of little nods you can turn with all of this stuff when it comes to different ways you can compare things, what IDE you want to use, what versions of things you want to use, blah blah blah. So it's easy to get kind of lost in those details. What's nice about these code labs is they have these kind of walk through one way of doing things and kind of get you going on that, and then you have a sandbox that you can play in to make other adjustments. So like you could take the same project and open it in Fleet, and it actually does seemingly clone with some Fleet settings in it. So it'll have like the right configurations and stuff set up correctly. So feel free to take a look at that on your own if you're interested.
I did. It was wonderful.
And yeah, I feel free to follow along with all this stuff in other ideas if you want. I'm definitely interested to hear kind of like what are people interested in digging into more, and what have you tried out? What works well for you?
Sure.
So feel free to let us know in the chat or on Slack, or next week you can talk. Hopefully we get moving a little quicker next week, so sorry about the delays tonight.
Not at all. Good show. Are there other questions on the virtual? I tried to make everybody a presenter, so if you wanted to unmute and ask anything, you could.
Oh, cool.
I'm going to stop the recording.
Sorry.